G'day everyone and welcome back. As you can see, I'm putting these 10 nanofarad capacitors back where they were and removed the 1 mic caps and the 47 mic electrodes. That's this board. But it also got me thinking, these references, when I traced them out, the two on this board are powered by a solid 37 milliamps, and the strange thing is, I thought originally that they were getting their power from Zenas and resistors. Well, here's the weird thing. This reference is positive, snakes around, goes all the way back to the end of this resistor, which is also the end of this capacitor. So it doesn't go through this resistor, it goes straight back to that rail there, which is again a midpoint. That's the negative of a capacitor, which is connected to that. I'll just show you all so it makes more sense. Reference goes to there, that resistor, right? That resistor goes to here. The other end of it goes to, I can't remember, that diode. But this end of it connects to this pin, the end of this resistor, this resistor, wait. Hold on. What am I missing? Sorry. This end of it, the positive side goes straight back to the end of that Zener. The end of that resistor, and these two caps, which is the center point, because that's the positive side of one, that's the negative side of another. So the other side of it goes through that resistor, and then the end of it goes, to that diode, and the end of the diode goes to this resistor, and then the end of this resistor goes off to the other board. But here's the thing, right? That's a 100k or a 10k. I keep getting my freaking oranges and yellows mixed up for some stupid reason. 10k. Yeah, it's orange. Obviously we're not getting from a 30 volt rail enough current to power this through a 10k resistor. Even the 1.8k resistor is only able to source like what, 1.52 milliamps, something like that, in that ballpark. Not much. So where's the rest of the current coming from? I started to wonder. First I thought maybe the person that replaced the resistors had put, you know how there was some 3/4 watt ones that were burning up and they were clearly replacements. I replaced these 1 watt ones. Well, I thought maybe someone had, put a couple of incorrect values in. But I'm not 100% certain on that yet. Like I said, the current is low here compared to the two other references run at 37 milliamps, and these two run at 6 milliamps. I do find that a little bit odd, but when I looked up the data sheet for the BZY88 3V6 diode, C3V6 diode that was here, I got the data sheet for it. It's actually spec'd all the way down to 5 milliamps. So maybe that's how that's supposed to be working. Again, like I said, the TL431's fine at 5 milliamps anyway. So, and as you saw, the current doesn't disappear, the voltage does. And not the voltage supplying the dropper resistor and the other end of this, but the voltage just across the reference. So it's the reference itself that's changing its own voltage due to oscillation. So I guess that resistor value is correct, or whatever resistor values it gets its power through. But basically what I'm getting at is it's a bit strange. It sources a couple of milliamps through that resistor and then that power rail, I think, or something like that, and the rest of it sort of comes off of one of these connections off the other board. And when I was looking at the other board to see where these references get their power from, interestingly enough, they come off basically the resistive divider that comes off of the voltage set pots. I know there's so much in here that doesn't make sense, and I really can't be bothered tracing it all out unless I have to, but the point I'm getting at is I'm now wondering if I might have to actually remove the capacitors on here. The thing I'm worried about with TL431s is they have a stable region, and if the capacitor value is too small, they oscillate. If it's too big, if it's too small, they don't oscillate, and if it's too big, they don't, but there's a region in the middle where they will go into oscillation. Now, the cap value I put on there keeps it outside of that region, but maybe not, because I didn't realize how small the current was. So, point I'm getting at is we might have to reinvestigate that. These things might end up needing bigger caps, like say 47 microfarads instead of 4.7, or they might end up needing no caps at all. That's something we're just going to find out when we get to it. But these ones don't oscillate. These ones are fine. So yeah, we'll just have to see. I'm going to get this board done now. Take these 4 caps off, these 4 caps off, put these 4 on. Then I'm going to put it back together and see where we're at basically again. See what the panel meter does when I turn the load up to 1 amp and start scoping around on all the various power rails, op amp inputs, op amp outputs, and see what's present in different places. Oh, and the references, of course. If you all remember, we actually already have looked across these references and there was a lot of noise there. I thought it was just Zener switching noise, but I'm not too sure now. Maybe that was literally oscillation. Just, you know, very high frequency oscillation. Anyway, I won't bore you guys, so I'll go and change all this off camera and then I'll come back and we'll put it together and see what it does and take some measurements. I was just having a think, and something I meant to mention, I probably should have mentioned it in my last video, but I guess better late than never. I was going to put LM7810 CVs in here instead of the Zeners that power the op amps. I don't know if I'm still going to do that or not. We'll see how... Oh, my cats are fighting again. Can you stop? This is going to be a real problem since one of my cats had kittens. They've all turned feral, which is a bit odd because all but 3 of them are desexed, so I don't know. Anyway, what was I saying? Yeah, the, what can we call it? I can't think. The LM7810s, 10 volt regulators. Don't know if I'm going to end up using them or not. If we get, you know, good enough performance. It all comes down to how much noise is present after the filtering and after the Zeners and the CMRR, the common mode ripple rejection ratio of the op amps. Basically how much of that ripple comes off the power rails and presents itself on the output of the op amp. If they do a good enough job of knocking out what's here, then I won't bother putting regulators in. If they don't, and I'm not happy with it, I'll put regulators in. So basically that's what that comes down to. So I'm either going to have an extra stash of 10 volt regulators with all my other standard 7805, 7809, 7812s and 7815s and 78 L05s and 78 R05s and all the other ones I've got. I don't have any 10 volt ones, so now I will have a pile of 10 volt ones if I don't end up using them here. So yeah, I guess I'll put them to use. Yep. Just retouching up all the joints that I've been heating up too many times. You know, putting capacitors on and taking wires on and off. Because yesterday I was taking disconnecting power rails and outputs off of these and running different tests. I ran a lot of different tests yesterday to see what was going on. I just decided that since I had only just worked out that the whole power rail design's basically the opposite of how I thought it was, I should probably have a bit of a look around the rest of it too. So I did that. Yeah. Alright. These ones, these two I can just, you know, the funny thing is that they had the capacitors not right across the op amps, but not right across the Zenas. They were sort of halfway down the tracks. And I don't know if they were using the 10 nanofarad capacitors to try and shunt the Zena noise, or if it was for the op amps as bypass caps. Or did they have a scope on the output of the op amps or whatever and literally moved the capacitor down the track up and down until they found the sweet spot? I don't know. So what I'm doing is I'm just going to put them back roughly how they had them in the first place, basically. Like that's why I've put these ones where they were. And originally they had the two 10 nanofarads that are doing 2 op amps sitting on these 2 rails that were powering in between the 2 op amps, the power rails. So what I'm going to do is I'm just going to tack it onto the positive point there and just run a bodge wire over to this ground point in between the 2 op amps so that it's still effectively, basically still in the same spot. It'll do. And with these ones up here, they didn't have them on the power rails right across the op amp. They had them around about there, I think. Can't really remember actually. So I'm just gonna stick them there. But yeah. I'll be back soon. I'm not gonna bore you guys watching me installing capacitors. You have watched me desolder and solder and desolder enough crap on this thing. I'll be back soon. Right, so that's all the capacitors removed, the electrodes and the 1 microfarad monolithics. The 10 nanofarads are put back in place. So I'm going to put this back together now. Just with the boards the right way up to start off with, and we'll just see how it behaves. Does the panel meter still kick back? You know, blah, 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 blah. How much of the offsets changed? Because you know how to put trim pots on the constant current and constant voltage pots. I have to do something about these cats today. Yeah, I'll be back. This isn't good. I can't let them hurt each other. Alright, so I've got even more good news. Remember how I always said that I was confused if the panel meter kicking back, if that was from oscillation or the actual inputs of the op amps going out of range? Well, check this out. 100 milliamps. Almost 200, and I've already been winding the pot down. I don't know if you remember when I first got this thing, one of those pots was wound all the way up and the other one was like wound all the way down. Well, I copied one to the other and it seems I copied it the wrong way. Now, if this is feeding because of the way this is trimmed, exactly double what it should feed into the input, there is a good chance it's going out of range. So I'm turning this down until it's displaying 100 milliamps. It's a bit fiddly here. Which I'm approaching. After turning it a good 10 turns already, I'm still going, about 5 because I'm going in half turns, but still, I think this is a 25 turn pot. Tell you what will be easy, I'll set it at 200 milliamps. Because there's a 200 milliamp dot line on the screen and I'm very close to it now. Very close. I'm doing this at a low current, by the way, because if I do it at 1 amp, the current resistor will warm up and the current will be slowly drifting, which will be very hard to calibrate it whilst it's drifting, right? So I figured I'd do it like this and then check it. Alright, now I'm going to wind it up. 400, and we've got 400 on the meter, that's good. That's interesting. It only goes up to 0.8 now, but it doesn't kick back. And as you can see on the meter, we get the whole amp. Let me show you what I'm saying. So, $200 milliamps, bang on. 400, bang on. 6, bang on. 1 amp, 800. That's the end. I mean, it's good news, it's not kicking back now. That seems to me like the op amp just needs more gain now. Which makes sense because I changed the op amps. And I don't know exactly how everything's laid out in here. I might have to change some things on some op amps. But there's no kickback now. It just seems like the total output voltage that's supplied to the panel meter. Although actually no, that can't be gain because that's not linear. Yeah, no, I just carried to something. That is linear all the way up to about 0.6, 0.7. Hold on. It's linear up to 0.65. Oh no, 0.6. Yeah, it's bang on at 0.6. And once I go over 0.6, the needle slowly goes up to 0.8. But as you can see, the current's, you know, the whole amp. That's what I'm talking about, the resistor warming up. It's a little bit of a problem as stuff warms up to calibrate stuff. Anyway, interesting, right? I'll go and calibrate the other meter now, so it's at least calibrated and we know it's calibrated, and then we just have to sort out the issue of why it doesn't work at the top end, but we're making progress. At least something's happening. Oh, I'm going to have to pause the video because I'm going to have to get the board out on the side basically to do this. Alright. My fuses are away too. Alright, I'll be back soon. Okay, so I calibrated those pots. That's sorted now. Let's have a quick look and see what the current is across these top references now, because like I said, about 1.5 milliamp, 2 milliamps is sourced through resistors from a power rail, but the rest of the current sort of comes, I think, from the output of an op amp, or maybe the output voltage, or like one of the other rails or something. I don't know. I can't tell you honestly. I haven't traced it out. All I know is that the bottom references had 37 milliamps on them and the top had 5, and I just want to see if it's still the same now that I've done what I've done. Still the same. Alright, let's load it and let's see if that voltage on those references still drops. Oops, I'm going to read voltage like that. Tell you what, that wouldn't have been good if I put that somewhere else. Right, I'm going to turn the current up now. So that problem still exists. When we get up to an amp, we lose the reference. Alright, at least we know. Okay, so where does that take me from here? Well, I've calibrated both the panel meters. I've removed all the capacitors that don't belong in there. Next thing I'm going to do now, I'm just going to have a quick look with the scope on just either one of these top references, because as you have seen, the voltage across the reference drops, but the voltage from the resistor, like just imagine it was a Zener diode, not a reference. I'll show you what I mean. Imagine it was like this. When I measure the voltage across the reference, it drops, right? But the current across it doesn't. When I measure the voltage across the dropper resistor and the reference, from here and here, there's a solid 10 volts there, and it does not drop the whole time. Only the reference voltage drops. It still has its 10 volts going to it, and it still has its 5-6 milliamps there. It literally drops itself. So that's obviously oscillation, and it's causing something in the reference to screw up, in the TL431 to screw up. So, like I said, I want to have a quick look at that. I want to see basically what that is, what it looks like. I've got a probe here that's already hooked up, so that's handy. I'll just clip this in here. Maybe I'll clip it on that resistor. Yeah. And I'll have a quick look. Okay, so it's that same high frequency noise that we looked at before. It's 650 microvolts RMS and about 8 millivolts peak to peak. Alright, I want to see what it does when I crank the load up now. So I'm going to put the shorting link back in and start dialing up the current whilst I've got a scope on here again. And already I can see ripple now on the waveform. Okay, because this is interesting, there's actually something here. I'm going to take load back out, put the camera on the tripod and show you guys. Sorry, my hand's blocking the camera whilst I get it in the tripod. Just a moment. My apologies. Got to try not to hit the power button as I get it in here. Ah, fuck. Oh man. Can't do this. Alright, that'll have to do. I'm sorry if it's not the best, but okay. Alright, so I'm going to take my shorting link. I've got the panel meter set to amps, so if you can see the panel meter, you can see the current being turned up and down. You can see the shorting link. Now I want you to pay attention to the screen for a second, the scope screen. Have a look at the waveform on the reference. Now, this is just about a 1-2 milliamp load with the current turned all the way down, but have a look at what happens to the waveform instantly. it changes, right? Let's start winding the current up. Holy! You reckon eventually the TL431 can't handle that, and that's why all of a sudden it just goes, I'm out. I think that's what's going on here. It's pretty obvious. As I'm turning it up, we're approaching that spot where it drops down to 2.8 volts now, and sure enough, that is the worst. That last end bit there is really bad. Actually, it doesn't even get smaller until we get down to about 400 milliamps. So past 400 milliamps, as soon as you put a load on there, there's oscillation. Now, I don't think that that's necessarily telling me that I need to compensate that op amp that powers the panel meter. I think what we need to do now, obviously you start at the beginning of any circuit, but not always, but in this case, let's take the boards out, flip them upside down, flip the connectors around, and have a probe around on the bottom, and start trying to compensate the op amps for the inputs. I know they're still oscillating because I've popped the fuse twice now, and sometimes when I put a load on it, it just shoots straight up and tries to pump out like 12 amps. So it's definitely still oscillating, and I've currently got no compensation capacitor on the voltage monitoring op amp. The constant current one does. So to start off with, I'm going to put a capacitor there. Let's just take measurements first. Let's just take measurements first and then start adding capacitors. Let's just see what we've got as it is. Because actually, let me just think about this. Sorry. See, the annoying thing, I'm just going to have to split this board again. I think what I will do is I'm going to add 4 capacitors that were already there when I got the thing. The thing that annoys me is that there was a capacitor from here to here and another capacitor from here to here. I know what values and what caps they are, I've got them. But all the rest of the components that are in that network, someone's removed, and you can see that they've been removed because, well, you can see what holes are blank that were never soldered, and you can see all the rest had solder on them. So yeah, that kind of sucks. I don't know. Half the reason this thing's oscillating could just be literally because of half the compensation network already being missing. Wonderful, isn't it? That's what you have to deal with when you work on stuff that's been fixed by at least one other person multiple times, maybe a few people. It's worth it to me. Like I said, it's a beautiful old school supply, and I'm sure once I iron out the problems, I'll have something that will last me for a long time. So what I'm going to do, I'll put these 2.1s back in that were in there, and was there a capacitor there in the first place? I'm just going to count out, because I know how each op amp had its own compensation capacitor. Did the top ones? Yes. So let me just count out how many of these little polystyrene capacitors I've got, because if I've got the same amount as op amps, that means that there wasn't another 2 on the inputs of the voltage op amp, and if I have an extra 2 left over, then obviously it was, and I can work out what value they're going to be because I know what values the compensation capacitors were. Only 2 of them were a different value, and I know what they were, so that's not going to be a problem for me. I only had 100s and 120 picofarad compensation capacitors. So if there's anything else in here, I think it was 100 and 120. When I read them all, I'll be able to remember. Right, that looks like all of them. Let's see how many we've got here. There's 1, 2, 3, 4, 5, 6, 7, 8 op amps and 1, 2, 3, 4, 5, 6, 7, 8 capacitors. Okay, so that was just the compensation capacitors. There's some different values there. There are some what? I don't know if I read that upside down now or not. Oh, let's see. Well, there's 120s, there's 68s. Yeah, there's 2 68s and the rest are 120s. Picofarad. Yeah, right. What other capacitors did I pull out? No, there's no other capacitors that would have been in a compensation network. Alright. Well, someone definitely removed a lot of parts from this. I'll put these two back in that were already in here for now, because that's how I got it. With the rest of the network missing, these look to me like they're only going to cause problems, but who knows. And to be honest, since I removed them, there's been absolutely no difference in waveforms or performance, so I don't even know if they're doing anything. I wouldn't be surprised if they're not really doing that much, because there's other components missing, and all those compensation network components, all the resistors and capacitors, they're all connected together. And obviously with some missing, it ain't going to be an entire network anymore. The thing that sucks for me is I end up looking up this PS601B-13B number, turned up no results. I even spent the night looking at old power supply designs, trying to find a schematic that looked like it was basically a copy of this, even if I could just find like, you know, something that this was basically a copy of, so I could get an idea. I couldn't find anything that was anything like this layout, so this truly is a one-of-a-kind power supply. The only people who are going to be able to tell me what was in here are the people that engineered it. And with how old this thing is, they're probably not even alive, let alone contactable. So it's up to us to work everything out from here. So that's them back in. Yeah. You can see the footprint here to put a resistor and a capacitor in parallel with each other across the two inputs of this op amp. This one's got just a capacitor across the inputs. There's a trace that goes from the other end of the cap straight to the input. So that doesn't have a resistor in series or parallel to it. But you look at how populated that area is, and you look at this capacitor here and follow its trace down to there. There's a trace coming off of a pin here that goes to, I guess that's for maybe putting an axial capacitor or a stand-up capacitor there, like an electrolytic. And that goes to whatever went there, who knows. And what was sitting there, what was sitting there, what was sitting there, what was sitting there, you know? What was sitting here. There's just so many unknowns. The only thing I know is that the compensation capacitors were sitting here. So, was this board meant to be like that from factory, and it was, you know, there was positions left for if they used, say, a different op amp, or this board was made up with different component values for different types of supplies, but they used the same board, or did someone remove components? I'll never know, because I'm not the one that fixed this thing over the years, and like I said, I can't get schematics. So this is going to be the biggest part of the headache, but it shouldn't be too big of a headache, I don't think. I think we're pretty much down to just compensating op amps. I'll scope out the power rails first, but like I said in the last video, now that I've discovered that everything is basically upside down to how I thought it was, and those capacitors were just basically shunting noise from one rail to the other, not actually decoupling it. Well, oh, and all these extra caps. What can you guys see one? Barely, shit. All these caps that I added to stiffen everything up. I'd imagine the power rails would actually be pretty good now. But let's have a look, and then let's have a scope of the op amps and see what we can see now. I'll just I'll stop this video because I'm getting hungry. I want to go get something to eat, and I've got to set up. I've got to put a book in here to cover some bits of metal, and I can't even remember how I had this. I'll work this all out. I'm getting hungry. I'll be back. Alright, I'm just about to do what I was just saying, make this upside down again so I can probe the bottom of this and tack caps on and stuff like that. But I'm gonna have to replace that copper tape again soon. I've already changed it twice. It's just the amount of times I'm sliding it in and out. But all good for now. It's only got to handle 1 amp. So I was thinking about something. Remember originally, sorry, it's just easier if I just grab them, I guess. Wait, how am I missing half of them? What? I'm missing a whole bunch of caps. Oh, that's right. They were all completely leaky. I threw them straight in the bin. There was 100 or 150 mic caps all here. I think they were 100. And then here, there was a 220, and then 100, and then a 220, and then 100. Obvious replacements. Now, the thing that I'm confused about, I'm going to have to trace out how the capacitors all wired up. Are they supposed to be odd values like that? Or did someone just do that because that's what they had? You know, I don't know. So I'm going to have a look at that too, just to make sure that we don't have imbalanced rails, because that wouldn't be a good thing. I doubt it. It's probably correct. It was laid out symmetrically, so it looks like it probably was correct. But just in case, I'm just going to trace out what sides, like this, where the center points are on each side of capacitors and what they go to, and work out, are these different value ones for single supply rail things, and these ones go to a center point, and the two outer connections go to, well, that's right, it's reverse. You know what I'm saying, but right? I'm going to trace down and work that out before I go any further, just in case that is incorrect and there's something wrong there. I don't think it will be, but just some, food for thought. I'm glad I looked into this. I think someone did just put whatever they had lying around. Maybe they wanted to put 220s all the way across and they only had 2 of them. I don't know what they were thinking, but so, for example, the center point that these 2 Zenas come off is these 2 capacitors here, and they're odd values. And when I went and traced out a few of the others, I've noticed the same thing in a few areas where it looks like it's either supposed to be a 2-stage filter or a dual rail network. The capacitors are not the same value on each side, like between the 0 volt and one rail and the 0 volt and the other rail. So honestly, looking at the sizing on the board but makes me wonder, but because the spacing for the holes. If you all remember, there was extra spacing provisionments just for these caps, but not the rest. So it's really got me scratching my head. It's like it was supposed to have bigger caps there. I don't know. I'm going to leave it for now, but I'm going to keep that on the top of my head, and if I have any sort of, you know, like 50 hertz ripple problems, 100 hertz rectified ripple problems, and I can't seem to track out why, and it seems like it's imbalanced, like more on one rail than the other or something, we'll revisit them and see if that actually is something going on or not, because I'm just not quite sure about it. It's a little bit strange if you ask me. These bloody brass pins that the boards connect together with are just beautiful. I've taken these boards apart so many times and I haven't done anything to these pins. I haven't tightened them up, readjusted them. They don't bend, they don't get loose. Like you can see, that's still tight. They just don't make stuff like they used to. You know, if I got to work on something these days, I've got to pull it apart that many times. I end up having to replace ribbon cables and sockets and stuff, you know. Things just aren't made like this no more. It's just, yeah, it's beautiful. Well, the burnt section's not too beautiful, but the rest of it is. So, I'll stop the video whilst I fit this. Okay, so I fitted the boards. It's in view. Yep, that's all in view. I fitted the boards. I've got one scope probe attached to the power rail on the 2 op amps on the lower board, the constant current, constant voltage ones. The first ones that look at the output voltage and output current and compare it against a reference. The first 2 op amps in the chain. This probe's on their power rail. And this is on one of the references on the lower board, the 5.1 volt references that are for the constant voltage section. Because I don't even know if I've looked at those ones yet. I know that they don't seem to present the problems that present on the top board with the 3.6 volt ones that drop down to 2.8. They stay solid at 5.1. I've tested that, but still want to have a look. So let's have a look. See what we've got. Oh no. What on earth? That is not good. I have not done anything to this. It was working just before. My connectors are the correct way around. Unless I've pulled a wire out of one. I'm not going to lie, I have been waiting for that to happen. You gotta be shitting me. Sorry about my language if I just swore then, but someone just did a knock and run on my door and it's been happening a little bit today. It's not something that happens. I live on a main road and yeah, anyway. I swear I thought I heard someone out there again. Anyways, I don't know what on earth just happened then. Okay, that's really not good. I don't know what's happened to the master channel. I literally just put the boards back in and powered it on, and it's, I'd say that's the whole 50 something, 55 volts that I'm getting. What on earth? The meter just said 16 ohms and it's on volts mode. I really got to fix that. Wait, what? Huh. You know what it is? It's the scope probe leads causing oscillation. Go figure. Go figure. I knew something wasn't right because I haven't changed anything. This is working. So there's no reason for that to be happening. I want them in times 1 mode just to have the first look at it, but once we find high frequency oscillation, I'll move up to times 10 because I don't want to load it down too much. I actually want to see what's there. Also, obviously, it depends how big the waveform is too, right? Oh, that's it. Sorry. Alright. Good thing I stopped that because I just flung my door open and screamed some naughty words out. It's the third time that's happened in about an hour. I've been sitting here and I still didn't find out who it was. I just opened the door and just started screaming as they were running off. And just running up to my door and going, and then just legging it. And I'm telling you, it's bloody pissing me off. Anyway, if it happens again, I'm likely to go flying out the window. Seriously, it's really pissing me off. I can't concentrate. Now, okay, I see what's wigging me out here. Well, I've got the red identifier on my probe that's marked green and vice versa. I keep looking at the other end of the lead that I want to pick up to look at the op-amp power rails. And I keep seeing red. I'm thinking I've got the wrong lead, but I just had the... There we go. They were around the wrong way. So, power rail... Oh god. Power rails on the op-amps. That's even worse than it was with the caps on there that I put on there. That's amazing. Interestingly enough, it looks like there's a little bit of like mains ripple there that's half rectified, but it looks like there's something else riding on it. That just looks really weird. Let me just take some loading off and go up to times 10. See if it looks any different. A little bit. Basically the same thing. Loading it down's not really changing it. Alright, well, that's not a good start. Let's move over and have a look at the reference, the one that's behaving, or one of the two that are behaving. Let's see what we've got going on there. Well, that's looking promising, but I don't know how far I'm zoomed out. Oh, I'm zoomed out. Hey, it's 300 microvolts, I mean RMS. Peak to peak's 2.8 millivolts. That could be quite alright for that part of the circuit. I don't know how this was designed, but I still don't like it. Might have a problem with these references not working out. That's certainly not as bad as what I've seen on the top reference anyway. The 3.6 volt ones for the constant current. Actually, let me just also put that probe into times 10 and... Yeah, I didn't think I was going to see anything more. You never know, it might unload it and produce a different, bigger waveform. It's always good to check. It's it's something a lot of people don't realise. I'm sure most of the people that are watching my channel understand all that, but in times 1, your probe bandwidth for a standard probe like this is only around 8 megahertz, 7 megahertz even, and the loading you've got on it in times 1, as you go up in frequency, it's really going to pull stuff down. So just be conscious of that. When I say loading, I'm talking about the line impedance, like the capacitive loading, the probe tip capacitance, the capacitance in the cable. Yeah. Anyway, I'm going to stop the video, move the probes around, because what we're going to do now is we're just going to look at the two references and the power rails on all the op amps and the inputs and the outputs, and just see if we can work out where the oscillation is basically starting at. Because I don't know if, out of the 8 op amps that are in there, if they're all oscillating on their own, or I would imagine maybe 1 or 2 of them are oscillating, and because they're all hooked up together, they're feeding into other ones. Like maybe the reference is buffered by an op amp and it's oscillating, and it's obviously then fed into these 2 op amps, so then they're going to be oscillating. Who knows? But from what I've seen on the power rail, I'm also wondering if there's some sort of resonance with the power rail going on too. So yeah, I'm still not sure that those capacitor values are correct either. So there's a little bit of digging I've got to do here, but I'll just pause the video and move these probes around now. Alright, so I've moved the probes to the input of the constant current op amp and the constant voltage op amp. Power supply's up and running, not in wild oscillation, just the oscillation it already has, which is pretty wild, I guess. So, well, that's pretty self-explanatory what that is. Just for those wondering what time base we're at. Yeah. What on earth? There's nothing loose there. Hold on. I don't know if my scope's triggering, did that? Oh. Wow. That's just me moving the voltage pot a little bit. Let's make that smaller first so we can see what's going on. It's almost trying to not let it happen. No, I'm joking. But as soon as I touch the pot, that's strange. That is very random. Alright, so again, we'll go to times 10 to oh, you know what, the switch. It was the switch. That's what it was. I knew something was loose. Right. But the oscillation does still change when I change the voltage pot. Alright, let's unload that and put it in times 10 mode. Doesn't seem to change as much now. So it seems like the more capacitance that's on the rails for the op amps in between their VCC plus and VCC minus pin is causing it to behave more erratically. Alright, that's what have we looked at? I think that's everything, well, for one channel on the bottom board I wanted to look at. Let's have a look at the output too. I mean, it's pretty obvious what's going to be on the outputs. We already know what's on the inputs, so... Actually, sorry, we've only looked at one of the op amps. That, by the way, was the one that's measuring voltage. This is the one that's doing current. Goodness. Now, I'm even more concerned about that. If you all remember, we have a really bad oscillation problem with the reference on the top board. I think we might be finding where this is coming from. Okay, that's good, that's good. Let's go to times 10. Doesn't really change. play around. Yeah, nice. Trying to play around with the current knob. Doesn't really change. Let me just find something to load it with. That'll do. Wow. So as you wind the current up, the waveform just gets bigger. Seems to be pretty linear with me winding the current up. And if you all remember, the reference goes crazier and crazier and crazier. The constant current reference, the 3.6 volt one, goes crazier and crazier and crazier the more you wind the current up, until eventually it gets that bad it just can't take it anymore. And it looks like we're seeing an exact copy of that right here. Isn't that beautiful? Jesus, okay. Wow. And it just gets bigger and bigger and bigger. Well, it's no surprise that eventually one of the op amps cannot cope. I'm surprised any of them can cope with that on it. Well, this is good because so far what we know is that there's some sort of mains ripple that's on the constant voltage op amp. We don't yet know if that's going to be a problem, because it might be a symptom of something leaking through from, I don't know, what we're about to dive into here. I say that because there's a capacitor sort of coupling the two op amp inputs together. We don't know what's going on with the power rails. I'm not so worried about that sort of mains looking stuff on the voltage op amp. I'm more concerned about the current one for now. That's, I think, where we're going to start. So, that being said, let's flip the board over and let's have a look on the top of it, because we've got, oh, you know what else I haven't looked at? I haven't looked at the output of this op amp up here, and I probably should, because I don't know what it's doing exactly. To be honest with you, see, like these ones, we haven't looked at the outputs of them because, well, we already know what's on the inputs. Do we really need to look at the output? No. This one up here, I actually don't know what it's doing. I'm not going to lie. I think it's a wise move to scope it out. So let's just have a quick look. I just don't want that going into oscillation, so I thought I'd just... You've seen the strange stuff it does. I've already popped 2 fuses. Right. Oh, wow. I was expecting something crazy to be there. It's not good, but it's... Compared to that current op amp, see, we don't know how this thing, without completely reverse engineering it, how it's designed, how they're filtering noise, how they're sinking noise out of different parts of the circuit, how much noise can be present in certain parts of the circuit without coming through to the outputs or ruining regulation. I didn't design it, I haven't reverse engineered it yet, so when I see small amounts of noise or main stuff, related stuff, I'm not going to let that worry me for now. That's in times 10 mode. Let's just go to times 1. I'm not going to let that worry me for now. I'm going to worry about this really ridiculous, huge oscillation problem that's in the constant current circuitry that just gets bigger and bigger as you turn the constant current up, and you're screwing the reference up. I think that's the obvious place to start, right? It's the worst thing that's happening in here. As you can all see, it's just high frequency noise. About 10 millivolts RMS, 72 millivolts peak to peak. One thing I just realised, a couple of the figures I might have read to you could have been wrong. I can't remember if my probe was in times 10 or times 1, but it's in times 1 for this, and the figures I just read you are accurate. So quite a bit there still, but yeah. Actually, you know what? Let's just load it and see if that gets bigger. Oops. Should probably have done that first so I can see if it goes nuts. Yeah, okay, that op-amp seems to just be dealing with constant voltage reference or something like that. Doesn't seem to be related to the current circuitry. Alright. I'm happy with everything. Well, I'm not happy with what I've seen. I'm happy, how do I explain it? That I've seen what I've... That doesn't make sense either, eh? I am happy that I have sufficiently scoped out what I need to scope out on the bottom of this board. Certainly not happy with the results. Soldering iron went to sleep, just give me a sec. I really got to order that, I think 6 core silicon cable, because the cable, like I said, I ordered a piece of silicon cable for this because it didn't come with silicon cable, but it's only got 5 cores in it. So obviously I need my ground and I need my temperature sensor and I need my elements, so that's 5 wires. I wasn't able to run the 6th wire, which goes between ground or one of the other wires and a little, like a mercury tilt switch or something like that. Probably not one of those, but something that detects you picking it up and moving it. And anyway, that's not going back to the base station at the moment, so I really need to do something about that soon. Let's have a look and see what's doing on the top board with the reference that was going absolutely nuts. It's a little bit fiddly getting it in there, but I'd rather take my time than just, force it in there. Alright. How am I going to do this? I think I might just solder... it's alright, I'll just use a clip lead for this. Obviously we're going to see a little bit more noise, high frequency content due to the ground loop, but I think everyone here is experienced enough to see through that and know what's actually there and what's not there. I am, so it's not going to bother me. Okay, so we're on times 1. This is probably going to be a ridiculously massive waveform. Isn't it funny how when you say something, the exact opposite always happens? I love that. That's life for you. And yeah, the probe's on times 1. Voltage isn't going crazy good. Alright. Let's see what happens when we load it. Yeah, as suspected. Man. Hey. Well, that's interesting. It has different modes of oscillation that it goes in between. wonder what it does when it gets up to that point, but it stops working. Nothing just stays like that. Interesting. Oh shit. Not good. Alright, well, man, this thing breaking out into oscillation is not good. I'm going to keep popping mains fuses. I'm not going to lie, I've put a 3.15 amp fuse in there just for now. Trust me, it still pops. I actually already popped one today. It just takes about 3 seconds longer to pop. But I usually notice it straight away and kill the power before anything bad happens. Nice solid transformer anyway. It's not going to melt its windings in a couple of seconds. I'd be more worried about the pass transistors and stuff like that. Anyway. Alright. So, now I'm left with trying to sort this out. I wasn't expecting the reference to be like that. You know what I just realised? We're going to have to do that test again. I just had that probe hooked up on the slave reference and I was loading the master down. That is probably why we saw a change but we didn't see it get bigger. So let's redo that test. This time on the slave channel. Wasn't that bigger? Oh yeah, that's about where it was, I guess. Alright, loading. Oh god. Sometimes, as you see, it just goes straight into oscillation and peaks, and you know, I already know because I've seen my fluke meter tell me that it's putting out 12 amps. So, not good. I can understand why I move quick when I notice that. Yeah, see. It actually turns into that oscillation and then it starts to get bigger, right? Oh my goodness, it just keeps changing. You know what, let's go back down, put my probe on times 10. Just to take some loading off of it. And we'll have another look and see what it's doing. No, it's not the probe. But you never know with high frequency stuff if your probe's going to load it down, so it's always worth checking. Making sure you get the same behaviour on times 1 and times 10, so you know that what you're looking at on times 1 is not a byproduct of you loading the circuit down, basically. Actually, did that just change? Oh no, that's the same waveform, it's still jumping around a bit. Alright. Well, I guess we've got... I can't be too upset. I mean, I've discovered quite a bit today. The whole power layout for these boards is the complete opposite of what I thought it was. And it seems like the source of the oscillation seems to be the reference. The TL431 seems to be oscillating like crazy. I'm not sure it is. I guess we could always, just as a test, there's two things I could do to test that theory. I could knock up another TL431 exactly like that, but without any capacitors, and take the MKT capacitor off the other side of the board that's in parallel to it. So it's just running as a diode basically, because, well, that's how this thing was designed in the first place. Try running it without any compensation capacitors. See what that does. Does it still oscillate? The other thing I could do is I could take it out and put a Zener diode in there and see if there's oscillation on that. But the thing is, changing it to a Zener diode is not going to really help me too much, because if it does go away, how do I know that it's not just because I've put a Zener diode in there, you know what I mean? So I think what I'm going to do is just knock up a TL431, same as that, just I'll take off the MKT capacitor off each one. I'll just do it for one for now, in case it only makes it worse. And I'll make up another one of these little boards I can just drop in, but like I said, I won't put any capacitors on it. It'll just be the TL431 with a resistor between the reference pin and the anode and cathode. You know what I mean. Yeah, anode and cathode before the dropper resistor. Alright, I'll pause, I'll stop the video to do that, because I've got to go grab TL431, find out if it's what pin out it is, because they have different pin outs, set the voltage on it, all that good stuff. I'm not going to bore you with that, because you've already seen me make up these ones. I'm just going to do the same thing again, and I'll be back. You know, guys, I'm just having a quick break to have something to eat, but excuse me, it got me thinking. These are only seeing 5 milliamps, 6 at the most. These are seeing 37. Now, there is noise on them, but it's not like this. I'm wondering if, because I've got so much capacitance on there and it's got such a little current feeding it and such a low voltage, that it's causing a seesaw effect. The TL431's having trouble going into regulation, whilst the capacitor's having a pole effect and also the charging effect of it. You know, at such a low current, low voltage, it might be struggling to do its thing. And that might be why those are not struggling so much. I'm going to finish my food and build up one of these, like I said, with no caps on it. We'll see what happens. Alright, I've just thought of something else, guys. I added a common mode suppression network to both the outputs on this thing, which comprises of two 1 microfarad MKT capacitors going from each output terminal. They're wired in, like, if you could just imagine, they're wired in series, and then, you know, each end goes to each terminal, positive and negative, and the center point goes to a 100 ohm resistor, which then goes to the ground terminal. Now, this thing has got crazy ass wiring looms in it, and it's thin wire, so it's got resistance to it. And I don't know if anyone's familiar with ground loops, but it's very, very easy to pick up ground noise because you don't have stuff star grounded and you've got wires looping around the place and stuff like that. And what I did by putting that 100 ohm resistor going from that common mode network straight to the green terminal on the front panel isn't honestly the best idea. I've actually had a problem doing that on my own supply that I'm working on at the moment. I got lazy. Actually, I'll just show you guys quickly what I'm on about. It'll make a lot more sense. Oh, I can't put the flash on. Apparently my battery's too low. Damn it. That's not good. I have to plug my phone in. So down there's a couple of huge capacitors going to a 100 ohm resistor. Originally, I put that 100 ohm resistor going to this ground post here. Right? The ground post. Which goes back to a star grounding point, which is just a huge lump of solder with a lot of different ground wires going to it. Anyway, when I put the scope on my output, there was still a little bit of common mode noise there. When I then removed the link from the 100 ohm resistor, which was then just going to literally, where was it? No, it was going to here. Yeah, the ground lug. And then I'd wired a wire from that going to the front panel, which is what this wire is. Anyway, I ended up having to make up 2 new wires going back to star ground. And when I did that, bada bing, bada boom, all noise gone on the outputs. So you see how thick and short the wires are in there. You see how thin and long the wires are in here. There could be quite a bit of noise coupled onto that ground terminal at the front panel. So I'm going to try disconnecting the 100 ohm resistor from that, and having a look at the what looks like mains hum, whatever you want to call it, ripple, and rectified mains ripple on those op amp inputs, and see if it's got anything to do with that or if it's coming from somewhere else. But that's something else to consider. It's quite possible that it is that. Very, very possible. That's honestly, to tell you the truth, also another reason why the main thing I'm focusing on right now is this main oscillation problem with the TL431, which looks like a TL431 oscillating, if I might say. I have seen them break out into oscillation before, and they make extremely funny looking waveforms, especially on a scope that's only 100 megahertz. It can't display really, really high frequency stuff, so it just, yeah, that's what it looks like. So I'm gonna go finish my food and that, and come back and make up this TL431 without the capacitors, like I said, and we'll go from there. We'll see what happens. But yeah, that's something else I'm gonna try, is moving that 100 ohm resistor. Well, just disconnecting it temporarily, and you know, if that gets rid of all that ripple, then I'll actually run, you know, 2 wires from each 100 ohm resistor from each output's common mode network all the way back to star ground, you know, with a nice thick straight length of wire, and that will obviously solve that problem. Alright, I'll be back soon. Alright, I'm back to work on this again. What I decided to do before I go and put the TL431 in there without any capacitors on it is I wanted to disconnect those common mode networks from the front panel like I was showing you guys, and see what difference it made. And I just, actually one thing at a time. So it's disconnected, that's the size of the waveform. Watch this. If I connect it, that's the size of the waveform. So it's actually helping out quite a lot, which is why I put them in there. They should still, that waveform would completely go away if I ran that wire star grounded it. That's exactly what happened on my supply. You know, I was just saying before, like joining it to the ground here instead of star grounding it to the back. Anyway, I'm starting to wonder if the mains that we're seeing there is actually just because, well, this is plugged into the mains, this is referenced to mains, ground loop on the input of op amps. I wouldn't be surprised. So, seeing as it's not a small signal, I've got some like cheap shitty little scopes in here, but they can only see like down to 50, 20 millivolts of division, something like that. They're rubbish for nursey crap. But I just have them for portable stuff, like looking at the timing pulse on a car, for example. It's really easy for me to... Whoa! No. One moment. Oh, God. I just knocked my lamp down. Sorry, guys. Just trying to get it back in place. I don't know how I ever had it standing the way I have it. Anyway, I'll do for now. Way easier to take this outside when I'm working on a car than to drag that outside and try and plug it into power. So that's why I got that, if anyone's wondering. seeing as the signal is, like I said, not small, it is, with the common mode network disconnected, 124 millivolts peak to peak and 20 millivolts RMS. We'll be able to see that on here. And what I'm thinking, well, this is obviously not plugged into the wall, so it's not referenced to mains. Let's see if that's still there on this. What on earth is going on with this thing? Let me just see what this thing's set to. I have not used this thing for so long, I can barely remember how it works. Alright, that's all good. That's alright. Man, why did everything just pop up in like that? Wait, why it disappears and you go up? What a weird thing. Where are my traces? Oh, that is channel 1. Like I said, I haven't used this thing for ages and it's a heap of crap, so it's not like I ever have used it a lot and got used to it. Right, okay. Let's see what we have here. That's good news. Doesn't appear to be anything there at all. I'm just going to put my finger. Might have to desolder this for a sec. Hold on. I'm just wondering if the trigger's got something to do with it. I really have no idea how this thing works, I'm not going to lie. Ask me anything about the Siglant, don't ask me about this. Have I put my waveform off the screen? I can't trigger. Ah yes, there is something there, it was. I moved my waveform off the trigger point. The trigger's at 50%, it says right there. Okay. So there's, you know, it's not, you can't even see it really. I don't even know if you guys can see that on the camera. Let me move that waveform up off the line and you can see it just a little bit more. But it's that small, it won't trigger if I move it up too far. Do you see that little bit of ripple on that line? Yeah, it's gone again. Well, can I move the trigger up and down? Like I said, I should be able to. Here we go. Alright, let me put this waveform not on a line and move the trigger up to my minuscule waveform. This thing's giving me the shits. How's the trigger on 50%? Ah, there we go. That works. So there you go. Can you see that little bit of ripple? Let me just have a look at the camera. I can't really see it. That's what I mean. You can barely see it. Don't forget this is only 50 millivolts of division, but still 50 millivolts of division, that's it, you know, it's completely gone away when it's not referenced to mains earth. So that is really good news. One, my common mode networks are helping out tremendously with all the common mode noise. I will actually ground them and do them properly. Two, all that mains ripple that we were seeing on the op amps, I'm right, it's not really there. It's just a byproduct of this being plugged into the mains, scope being plugged into the mains, and a huge ground loop going on. So, that is bloody awesome. All we have to do is get rid of that oscillating reference issue and we should be good. I mean, we might actually get this thing done tonight. Finished, completely finished tonight. Let me just pause the video. I knocked some stuff over. I've got to straighten a few things up. I don't want to waste your time. Right, I just had to straighten up the stuff my light was precariously balanced on top of, and a few other things that got knocked over in the process. So then, power off, soldering iron on. I'm going to take that probe off of there, take these boards back out now, and I'm just thinking. Yeah, I'm going to say that that's exactly what was happening. What I'm thinking. I'm just creating a ground loop there, so I'm just going to ignore that. Like I said, the common mode network at the front that I've installed, I will do it properly. I'll move that and star ground it. I'll do that now whilst I've got the boards out, because I'm going to have to lift the bottom panel out to get in there, and that's already it's not fun to get to, let me just say that, because I put non-axial capacitors on the output terminals. They sort of protrude further in than the back of the meters, and when you want to lift it out, they're in the way, and it's a bit of a fight. But I'm hoping that the earthing point is somewhere in the corner here, near where the power cable comes in, and I can just move it over just ever so slightly and run a couple of wires in there, under there, wherever the actual initial ground point is, and then bring those over to my common mode networks. But yeah, so I'll do that, and put that reference in. Like I said, just get a TL431, set it to 3.6 volts with no capacitors on it, and I guess we'll go from there and we'll see what we get. Alright, I'll be back soon. So I was just getting a TL431 out my drawer of spare parts. What should I say? Millions of drawers of spare parts. And I realised something else that got me scratching my head. That top reference, unlike the bottom reference that gets 37 milliamps, only gets about 5-6 milliamps. Now, you know what, I'm just going to use the calculator on my computer because, as I've mentioned, my maths is shit. But, hold on, you'll see where I'm going with this. If we've got a 50 kilo ohm pot, and we've only got at most 6 milliamps going through it, actually I need to know the current, so what I'll do is I'll put the voltage through it. 3.6 volts. Why is that hard to think? 3.6 volts across a 50k pot is 72 microamps. What's the TL431's reference pin require? I'm just looking, so I'll just move the camera up. If I can get it up that high. You know what, I'll just hold it. So, reference input current. 2 to 4 microamps. Well, that's good. Actually, what's the, oh no, that's the, yeah, right, yeah, that's IREF, okay. What's the minimum cathode current? Here we are. 0.4 of a milliamp. 0.4 of a milliamp. Alright, so we don't... Oh, no. Oh, you're not going to believe what Yeah, they just went in my coffee. All my USB connectors. Just give me a moment. Sorry. I gotta say, us people who do electronics... Whoa! I think I should just put those cables back where they were. Right. That's... No, screwed my stand up. Sorry, my apologies about this, guys. There you go. Right, now I've forgotten what I was saying. Doing good on this one. So... No, I've really forgotten what I was saying now. Oh, yeah, we're lucky, you know. I was just thinking just then, if someone, like a normal person, someone who doesn't do electronics, drops their USB connectors into their coffee, they'd probably try and wash it out with water or just dry it with a tissue and it would corrode, you know, not too long in the future. Us, we've got cleaning solvents and everything, IPA, we don't have to worry. We have a bit of an advantage on the rest of the world. There's all shit in my coffee now. That's wonderful. Anyway, so like I was saying, I'm glad I've looked at the data sheet because I can see that the TL431, in terms of the current its reference pin's going to see, and in terms of the cathode current running through it that's required for regulation, we're going to meet both of those criteria in here, even with the 5 milliamps. So that's a good thing. Alright, I'll knock this up with a pot and put it in there. I've already taken one in there off. It is here. And there's the new TL431, or the test subject. I've also taken the MKT off the back of it. I had this in parallel on the back of the board like this, if that makes sense to you guys. So there was a 4.7 mic cap there, but I also decided to add a 1 mic MKT later on. Right, so I'll put the pot on that and I'll install it, and then we'll put it all back in, stick the scope on it and see what we've got now. Alright, so just to show you guys, I don't know how I'm going to do this. I'll put that on the side because my cables are a bit short, but I've got literally just a TL431 and a pot hooked up here. And if I stick the leads across it, I've got 3.681. I'll just turn that down a smidgen. I was just doing that off the display on my power supply. It's current limited to about 10 milliamps. Alright, 3.59, so that'll be bang on now because that was reading 3.6 before. God. Let's see. Really? Yeah, it's good enough anyway for testing. We're not worried about the accuracy right now, we want to see if this oscillates or not. So, that is our new part ready. I'm just taking out the breadboard. So it's literally just the pot and the TL431. There's no capacitors, and there's no capacitors on the board. So I'm going to install this now, put everything back together. I haven't hooked up the common mode network on the front panel yet. I'll do that afterwards because I'm not worried about that now. I know that the mains ripple stuff that we were seeing on one of the op amps was literally ground loops I was creating myself with my scope. And I know the rest of it's going to be knocked off as soon as I connect that common mode network up to the front, as you guys saw. So I don't have any worries about that at all. The only thing I'm concerned about is literally getting rid of this oscillation, and then we can basically put it back together, or connect up those two common mode networks, put it back together, make sure everything's calibrated. Job done, finally. Took me long enough. Tell you what, I really had the aha moment as soon as I realised all the circuitry on these boards was basically powered upside down, in my own words. it's, as you can probably tell, started to make a lot more sense. So I'll go fit this now and I'll come back. So it's fitted there in place of the other one. I'm going to put that in there now and we'll see what we've got. Alright, so that's back in there. I'll just turn the power supply on before I put the probe on, make sure this is working. My luck. Oh no, that's on amps. Yeah, it's working. All good. Yeah, nothing wrong there. Okay, right. So let's just see what voltage is on it. Just for you guys. Good enough. Alright. Okay. Get one of my modified solderable probes. And I'm just going to literally put this on top of this reference because I want to see if it's still going nuts. I guess the capacitance of just putting this on here could actually make it go nuts. Let's still try anyway. I think in times 10 it would be enough load off of it to stop it from, capacitive load that is, off of it to stop it from oscillating, but who knows. Alright. Would you look at that? Really? Yeah, and that's on times 1. That is a lot cleaner. There's still noise there. RMS, we're looking at 1.6 millivolts now, which is an order of magnitude different to what I had before. I'm curious. I'm just going to hold an MKT 1 microfarad across it and see what happens to the waveform. Oh, it actually gets quieter. Interesting. I don't know what to make of that. Let's wind the current down and see what happens when we load it. Which side is this? No, this is the slave side, sorry. What's this side? Well, that's not good. Bummer, eh? Bummer. That sucks. I was really hoping that that would be the solution. Well, maybe we just need to go up in capacitance. It's a possibility. I only put 4.7 microfarads on there. Might tack one of these 47s across it. I'll tack one of these 47 mics across it. We'll see what that does. It's a good thing it's standing up here on a couple of pins because I can just kind of dead bug style stuff on it, which is very handy when you're trying to get something right. I was just shorting that capacitor out on my iron quickly just in case it had a nasty voltage on it. Right, that's 47 mic across it. Would you look at that? 2 millivolts peak to peak, 900 and something 1 millivolt RMS. So in actuality, it looks like we've got to go up in capacitance, not down. And that makes incredible sense. And look at that, I can load it and it's not going nuts. Let's see if the scale goes up to 1 amp now without kicking back. No. It just stops at 0.8. We're still making progress. That's a good thing. It's interesting that it still has the oscillation there. Now I'm starting to wonder if it is actually the TL431 oscillating or if it's coming from one of those op amps and ending up there. I don't know if that capacitor is just a temporary solution that's just damping out the oscillation there, so it's coming from somewhere else, or if it actually truly is that trying to oscillate. Yeah, that's a head scratcher, isn't it? If I put too large of a capacitor there, it's going to cause a problem too on startup, because if the reference voltage takes too long to come up, the output voltage is going to start high and then come down. Might even already do that with 47 mic on it, let's see. Ever so slightly. I wouldn't like to go bigger than 47, that would screw it. Oh, that was the wrong one I was looking at. Maybe that was just the needle kicking back on its own. Let's see. Oh. Well, that makes sense. Alright, let's see. I'll just short this cap out. Alright. Yeah, you see how that shoots up and then comes back, and that just, yeah. So that is a problem. If I increase that bigger, that will overshoot where it's set at. And, you know, that's a problem if you're working on something and you go turn the power off and turn it back on, and then, you know, you're going to pump over what it was set to into your circuit. Ah, God. What the hell? What's my cat doing now? Sleeping, that's alright. I think what I'm going to do, because one thing I've noticed about this supply that I find a bit strange, but there could be a reason for it, is that stuff that happens on one channel presents itself on the other channel. Like, you guys have seen me accidentally scope across the reference on this side and load the other side up, and this side still changed. The waveform didn't get bigger, but the oscillation changed. So I'm wondering if I should do that to all of the references. Yeah, I really don't know where to go from here, right? All I can do now is flip the board over, leave that as it is, with that 47 mic on it. Flip the board upside down and have a look at the inputs on the constant current op amp. See what's going on there. Is the oscillation waveform that we're finding down there gotten bigger? Has it gotten smaller? Is it still the same? Yeah. This is an interesting one. It seems every time I make a little bit of progress, and it seems we're almost, you know, around the corner and out of trouble. There's still more to do. Oh well. It is what it is, I guess. I'm too far invested to bail at this point. Alright. I think what I'll do is I'll upload the video here as it is for now, and then start on the next video, because this has got to be getting over an hour. I don't want to make people shy away from watching my videos because they go on for too long. And I think I've covered quite a bit in this video. So I'll leave off here. I'll upload this and I'll continue working. I don't know if I'll get the next video uploaded tonight because I might end up sort of making half of it tonight and then the other half of it tomorrow and then uploading it and then starting on another one. I don't know. But I'll leave off here for now, guys. And I'll keep going and I'll see you in the next one. I've got a bit of thinking to do, so yeah. Thanks for watching.